Hello guys, so we're going to learn how to solve and apply exponent properties involving quotients. Don't forget that you have the mind of Christ and that everything you can do it in the power of Christ. So, and here I have that I'll learn how to apply exponent properties involving quotients. These are some exponent properties. These exponent properties, I have them on this chart, but on this video we will not learn to apply all of this one. We will just learn how to apply the ones that are involved on a quotient. The ones that we will learn are the quotient of powers property and the power of a quotient property. The quotient of powers property tells me that the same base number raised to different exponents when they're dividing, I'll subtract my exponents. I have in this case a over m, a raised to the power of m, over a raised to the power of n, equals a m minus n. On this case, as you can see, my a is the same base on both, on the numerator and on the denominator. But my exponent is not the same one. So what I'm going to do with my exponent? Well, I'm going to subtract the exponents. Now, my power of a quotient property tells me that when I have two different numbers, just as a and b, but both of them are raised to the power of m, I divide each one and I place them like this. The a raised to the power of m and the b raised to the power of m, just as I have it in here. A raised to the power of m over b raised to the power of m. So we're going to make some examples so you can understand way much better these. In this case, I have x raised to the power of 4 over x raised to the power of 2. And I'm going to apply my quotient of powers property. That tells me that a raised to the power of m over a raised to the power of n equals a raised to the power of m minus n. That my exponents will be subtracted. So in this case, I have the same base but different exponents and they're dividing. So I'll have it like this. X raised to the power of 4 minus 2. Always the number of the exponent of the numerator will go first and the one of the denominator will go second. As in this case, 4 minus 2. And how much is 4 minus 2? Well, it's just 2. So my answer will be x raised to the power of 2. So let's make another example. On this example, I have h raised to the 15th power times 1 over h raised to the 4th power. What I need to do first, well, I multiply my 1 times this number, h raised to the 15th power, and I'll have h15 over h raised to the power of 4. Now, I have the same base number, and these two numbers are dividing. So I apply my property that tells me just write the base, and the exponents, you need to subtract them. 15 minus 4. Always the exponent of the numerator goes first. 15 minus 4. And how much is 15 minus 4? Well, it's 11. So my answer in here will be h raised to the power of 11. Let's make another example. Negative 2 raised to the power of 4 times negative 2 raised to the power of 3 over negative 2 raised to the power of 2. What I'm going to do? Well, the first thing, I apply my property that tells me that when they are multiplying the same base number, I add my exponents. That you can see those properties of products in the other video. And I add my 4 with my 3. This way I have negative 2 raised to the power of 4 plus 3. And 4 plus 3 is 7. Now, I can apply this property, quotient of powers property, that tells me that when I have the same base number with different exponents, what I need to do is subtract. This way I have negative 2 raised to the power of 7 minus 2. I subtract my 7 with the 2 and I have negative 2 raised to the power of 5. As you can see, it's really easy. It's just paying close attention so you can understand it really well. So let's make more examples about this. On this one, I have 2/3 raised to the power of 3. My property tells me that power of a quotient property. When I have two different numbers raised to the same exponents, I apply the exponent to each of the numbers I have in the fraction. So, I apply my 3 to the 2 and the 3 to the 3. This way I'll have 2 raised to the third power and 3 raised to the third power. How much is 2 raised to the third power? Well, it's 2 times 2 times 2, that is 8. And 3 raised to the third power is 3 times 3 times 3, that is 27. Applying this, I can find that my answer is 8 over 27. And if I cannot simplify it anymore, I leave it until there. Well, I'm going to do another example that tells me g raised to the second power times g raised to the second power over k raised to the third power. Raised to the third power, everything. So I apply my property that tells me that the m, the exponent outside the parentheses, I need to apply it to everything inside the parentheses. I apply it, and I'm going to have g raised to the second power times the g raised to the second power times 3, because I multiply my 2 with the 3, and the k raised to the third power times 3, because I applied this to the k. Now, I multiply my 2 with the 3 and the 3 with the 3. This way I'm going to have g raised to the second power times g raised to the 6th power over k raised to the 9th power. Now, I need to simplify it in more. And I have g raised to the second power with the g raised to the 6th power. I multiply these two numbers, and I'm going to have it like this. As you can remember, when I have the same base numbers, I add my exponents. So I add the 2 and the 6. This way I have g raised to the second power plus 6 over k raised to the 9th power. How much is 2 plus 6? Well, this way I have my final answer will be g raised to the 8th power over k raised to the 9th power. Okay, let's make one more example, and with this one we're done. But in this example, we're going to involve the properties we'll learn today. The quotient of power property and the power of a quotient property. Okay, I start defining that my example on here, I have 2y raised to the 4th power over 3y raised to the 2nd power, and everything raised to the 3rd power. Well, and here I can define that my 3 will be multiplying everything inside the parentheses, just with my power of a quotient property. And I'm going to apply it like this. 2 raised to the 3rd power, because I apply my 3 to the 2. And I also apply my 3 to the y raised to the 4th power, just as in this case. Now, I apply my 3 to the 3 I have in here in the denominator, and my 3 to the y raised to the 2nd power, just as you can see it in here. Now that I apply my power of a quotient property, I need to define that I will use my power of a power property. Why? Because as you can see, my y raised to the 4th power is raised to another power, that is 3. And my y raised to the 2nd power is raised to another power, that is 3. So now I'll apply it. I simplify my 2 raised to the third power and my 3 raised to the third power. 2 raised to the third power is 8, and 3 raised to the third power is 27. Now, how much is 4 times 3? Is what I'll place in here. And 2 times 3. I start multiplying and I have that 4 times 3 is 12, and 2 times 3 is 6. Now, can I simplify it more? Yes, I can simplify it more. Because as you can see, I have the same base numbers with different exponents. So I can apply my quotient of powers property. That tells me that when I have the same base numbers and different exponents, my exponents will be subtracted. So I have 8 over 27 times y raised to the 12th power minus 6, because I subtract my exponent of the numerator from my exponent of the denominator. And 12 minus 6 is 6. This way, my final answer will be 8 over 27 times y raised to the 6th power. Don't forget, guys, if you have any doubt, you can leave it in the comments below. And thanks for watching.